What's up everybody? In this video, we're going to create a working game of Hangman using Java. A user is going to guess certain characters, and we'll see if there's a match within a secret word. Near the end of this video topic, we'll be importing a file of words, and one of those words will be secretly selected. So let's get started. Alright, let's get started everybody. Near the end of this video, we'll have our program choose a random word from a list of words. But to keep this program simple in the beginning for testing purposes, let's create a string variable of word. Here we'll select a word that we're going to use throughout the program just for testing. Pick a word. For me, I'll say, you know what, let's go with pizza. So this will be my word. So we have our word. We'll be accepting user input, so we need a scanner. Scanner equals new scanner. Pass in system.in. Import the scanner class. And close your scanner at the end of the program. Scanner.close. Here's where we'll be working with array lists. We will create an array list of characters. To do that, we type ArrayList, then specify the type within a set of angle brackets. We can't use primitives, such as char. We'll have to use the wrapper class of character to store characters. I will name this array list word state equals a new array list. Use the diamond operator, set of parentheses, semicolon. We'll need to import this class. Now, within the diamond operator, you don't need to list character again, even though that does work. Java can infer what the type is. In the beginning, our word state is going to contain a bunch of underscores, and we're going to fill them in one letter at a time by guessing. We'll also need a variable to keep track of our wrong guesses. Int wrong guesses. This will initially be 0. We'll set that equal to be 0. Within our array of word state, we're going to add an underscore for every letter within our word. We'll create a for loop that will cycle once for every letter in our word. Here's how we can do that. So we'll start with a basic for loop, create an int of I for index equals 0. We'll continue as long as I is less than, take our word, and strings have a built-in length method. Return the length of this word. So in this case, it's going to be 5, because there's 5 letters in this word. Then increment I by 1. During each cycle of this for loop, we're going to take our array of word state and add a character by using the add method. We will pass in an underscore character. Be sure you're using single quotes, not double quotes, because these are chars technically, not strings. Alright, let's do a test run. I'm going to output our word state to see what we have. So we should get 5 underscore characters. And we do. 1, 2, 3, 4, 5. P-I-Z-Z-A. Throughout this game, by guessing letters, we'll be filling in this word state by replacing the underscores, if there's a match. Let's change this word, just so we know that everything's working. I will pick watermelon, because that's the first thing that came to mind. So watermelon has 10 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, we know that that works. I will switch it back to pizza. Delete this print statement. And we can move on. Word state is an array list made up of characters. Currently they're all underscores, but we'll be replacing each with a character if we get the correct guess. After the for loop, why don't we create a welcome message? Let's say, welcome to Java Hangman. Now you don't need to do this, but I'm going to add some decorators. Just a bunch of asterisks, before and after. Again, you don't need to, but I think it looks cool. Let's make sure everything looks okay. Welcome to Java Hangman. For our hangman, we're going to display some ASCII art. Outside of our main method, we're going to declare another method that's in charge of returning ASCII art based on the number of wrong guesses that we have. This will be a static method. It's going to return a string. We'll name this method getHangmanArt. We will have one parameter. We have to pass in how many wrong guesses we have. Then, depending on the number of wrong guesses, we'll return a certain image, represented as a string. Within our getHangman method, we'll be returning a string representation of our ASCII art. We can best do this with the switch. Now, a switch can return something. We'll use the return keyword, create a switch, end it with a semicolon. Within our switch, what are we examining? We're examining the number of wrong guesses. This will be a number 0 through 6. We'll need a case for each of those numbers, for each of those guesses. Depending on how many wrong guesses the user has, we'll display one of a few images. So here we'll be working on our art skills today too. If we have a matching case, where wrong guesses matches a case of 0, that means they have no wrong guesses. Case 0, arrow, meaning do this, will return the following. In Java, you can write a multi-line string, but you have to use a triple set of double quotes. And I'm just going to line these up. Within this triple set of double quotes, I'll have 3 empty lines between them. We won't display anything if the number of wrong guesses is 0. Then for case 1, if a user has 1 wrong guess, we'll display our man's head, represented by an O. If wrong guesses is 2, we can represent that with case 2. We will draw the man's body, represented by a vertical bar. Case 3 will be the left arm. For the left arm, we'll use a /. For case 4, that'll be for the right arm, we'll use a \. In Java, a \/ is actually an escape sequence. To display a \/ we have to use double \/. Case 5 will be for the left leg. It's kind of like we're assembling Exodia, if you know the reference. And then case 6 is for the right leg. We'll need 2 \. We'll want a default case if there's no matching cases. We'll just return an empty string, just to make Java happy. Alright, and this method is done. Based on the number of wrong guesses, we'll return one of a few strings. Let's test it. I'm going to use a print line statement, call our getHangman method. We'll start with 0. 0 wrong guesses. We should end up displaying 3 empty lines. If wrong guesses is 1, we should display the hangman's head. 2. 2 is for the body. 3 is for the left arm. 4 is for the right arm. 5 is for the left leg. And 6 is the full body. That's when we lose. When wrong guesses is 6. Alright, we know that the getHangman method works. I will collapse it because we're done with it. To get the art for our hangman, we just have to call this method, then pass in the current number of wrong guesses. Let's delete this print line statement, we no longer need it. Now, when we print our word state, let me show you. We get this ugly formatting, where we have a set of straight brackets, then all the underscores are comma separated. We can customize that. So here's what we'll do. After our welcome message, we'll output the following. We'll output the word, :space. I'll use print. I want to stay on the same line. We'll create a for loop, an enhanced for loop. For every character in our array list of word state, we're going to display an underscore with no formatting. Using an enhanced for loop, we have to list the data type of what we're cycling through. We're cycling through an array of characters. Char, a common convention with enhanced for loops, is to name each letter C, because we can't use char because that's a data type. And character is kind of long, so C is short for characters. For every character of C in our array list is named word state. We'll do the following. We will output our character of C plus a space. So then when we output this, Oh, let's use print rather than print line, because we want them all in the same line. That's much better. That output looks a lot nicer. Each letter is an underscore. They're all separated with a space. When we guess each letter, we'll be flipping these underscores to its matching character, if they do match. I'll add an empty print line just so we go down to the next line. Okay, for the next part, we'll have a user guess a letter. We'll need some user input. We'll need a prompt. Guess a letter, colon space. I'll use print, not print line. We'll create a variable of guess. Guess will be a letter. We'll need to accept user input. We'll need to accept user input using our scanner. Scanner.next. Next will get the next character. Now, since we're working with lowercase characters, we can method chain the to lowercase method, just to make it lowercase if somebody types in an uppercase character. To lowercase. Okay, to lowercase method. Using next, the user input's going to be a string, not a character. We can easily convert that to a character by using the char at method. But we have to pass in an index. We're only accepting a single character, so we'll use char at 0. We're telling Java, with the string that the user types in, give me just the first character, and convert it to be a char. So guess is going to be a single letter. It'll be of the char data type. Alright, then let's test it. I will output our guess. I will guess an uppercase P. We'll end up outputting a lowercase p, which is good. How about a z? Yep, our guess is z. If I were to type in a full word, like pineapple, we still end up with just the first character in our string. Which is good, though. Let's delete this printline statement. We no longer need it. For this next part, we're going to check to see if our guess matches any letters within our word. We'll use an if statement for that. If, take our word, it's a string, in this case pizza, we'll use the built-in index of method, and then pass in our guess. So basically, with the index of method, it's going to return the index within the string of the first occurrence of the specified character. For example, let's say I guess the letter Z. Well, Z is in the word pizza. It's at index 2. That's the first occurrence. If my guess was Z, index of is going to return the number 2, because that's the first occurrence of Z. We will check if the first occurrence is greater than or equal to 0. That means there's a matching letter if that's the case. If there's a matching letter, we'll output correct guess. And then I'm just going to add a new line character to the end. All right, let's do a test run. I will guess the letter Z. That's a correct guess. But are there any X's? There is not, so we don't output correct guess. If it's the wrong guess, we can output, using an else statement, wrong guess. Then I'll add a new line character to the end. Let's try that again. I will guess an X. Wrong guess. There are no X's in the word pizza. Okay, so within our if statement, if we get the correct guess, we're going to change our word state to reflect it. That's one less letter that the user has to guess. We're going to cycle through the length of our word using a for loop. For int I equals 0. We'll continue as long as I is less than our word's length by calling the length method. Then increment I by 1. We have to see where there's a match exactly, which index within our word. We'll use an if statement. We will take our word, in this case pizza, call the char at method, then pass in our index of I. During each cycle, I is going to increment, but during the first cycle, it's going to be 0. So we're saying, take our word, in this example pizza, give me the first character. So for pizza, that would be the letter P. Is that equal to, using the comparison operator, our guess? So let's say I do guess P. The first character of my word is P. That means that they match. We're going to take our array list of word state, and we're going to update it by using the set method. We have to pass in an index and a new value, our guess. Let's test it. So with the word pizza, are there any Z's? Correct guess. Oh, then we have to output it too. We're going to continue playing as long as wrong guesses is less than 6. Once wrong guesses is 6 or greater, then the game ends. So let's cut this portion of code. Cut it, don't delete it. We'll write a while loop. While our wrong guesses variable, wrong guesses is less than 6. We'll continue playing this game. Within the while loop, we'll paste all that code again. Let's do a test run. Guess a letter. I'm going to guess Z. So that should update our word to reflect 2 Z's, because my word is pizza. But if there's no matching letters, it doesn't get updated, because there's no matches. Let me fill this in. P-I-Z-Z-A. And we get the full word. Alright, that's good. So far, so good. So we'll need to keep track of wrong guesses. Within our else statement, we're going to take our variable of wrong guesses, increment it by 1 using the increment operator. Then back to the beginning of the loop, we're going to display our hangman art by calling the getHangmanArt method. This method will return a string, so we can put that within a print statement. Let's use print, call the getHangmanArt method, then pass in the number of wrong guesses. Let's do another test run. We have 3 empty spaces, because we haven't displayed any parts of the hangman yet. I will guess the wrong letter, X. We get the head of the hangman. I'll guess some more wrong letters. C, V, B, N, M. At the end, we'll have to display the full hangman when we lose. Let's display the right letters. P, I, Z, A. Okay, good. What happens when we lose if wrong guesses is 6 or greater? So outside of the while loop, our while loop ends right here. We'll write an if statement. If our variable of wrong guesses is greater than or equal to 6. Okay, we will again use a print statement called the getHangmanArt method, and then pass in the number of wrong guesses. We'll also display a game over message. Game over. Then display the word. The word was :space plus our original word of pizza. Let's do a test run again. I'm gonna guess the wrong characters. Alright, game over. We display the full hangman. The word was pizza. I think I'm gonna make a few changes. I'm gonna remove these new line characters. It's a little too much space, I think. Alright, we're good. So, how do we win? Let's add that after the for loop. If we get a correct guess, we'll check to see if our word state doesn't contain any lowercase characters. So take our array list of word state, call the contains method, and then pass in an underscore character. But we want to check to see if our word state doesn't contain any lowercase characters. We can prefix this with the not logical operator, an exclamation point. If our word state, doesn't contain any lowercase characters, that means that we guessed all the letters, and we win. If that's true, let's display our hangman one last time. System.out.print, getHangmanArt, pass in the number of wrong guesses, and we'll display you win. And display the word again. The word was : space plus our word. Then we'll want to break out of this loop because we're stuck in a while loop. We can use a break statement after we win to break out of the loop. All right, let's see what we're working with. I'll guess a few wrong letters. X, C, V, B, N. All right, one more wrong guess and I lose. Game over. The word was pizza. All right, I'll actually win this time, but I'll guess a few wrong characters. Q, W, E, R, T. I'll guess some correct characters. A, Z, I, P. You win, and we display our current score. The current state of our hangman. We display you win. The word was pizza. In this next part of this video, we're going to create a more advanced version of this program by importing a file of words. A word is going to be randomly chosen from a file, instead of just setting one in the beginning. Okay, everybody, in this next section, we're going to create a file that contains all the words that we can possibly use for this hangman game. Within our project folder, why don't we create a new file? File, new, file. I'm going to name this file words, and this will be a txt file. For all the different possible words in this game, place within this file. You can copy and paste them from somewhere online if you would like. Just to make reading this file as simple as possible, I'm going to list all the words on a separate line. So think of some words, or like I said, copy and paste them from somewhere. I'll just add several. Apple, orange, banana, coconut, pineapple, grape, lime, lemon. That's good enough. In my project folder, I have this file, words.txt. Temporarily, with my game, I'm going to write a multi-line comment and just comment all of this out until we're ready to bring it back in. At the top of my hangman game, I will create a string named file path. This will contain either a relative file path or an absolute file path. Since this file is in my project folder, I just have to list the file name, words.txt. We're going to read this file line by line. We'll store each word in an array list. We'll create a new array list. Array list. The data type is going to be strings. So, string. I will name this array list words equals new array list, diamond operator, parentheses, semicolon. Now we'll actually need to read this file. Reading files is considered dangerous code, because it's highly likely that something can go wrong. We will write a try with resources block. We need that set of parentheses after try. We will catch any exceptions. When you try with resources, you'll automatically close any resources listed within the set of parentheses. Within the set of parentheses, we will create a buffered reader object. Buffered reader, which we will name reader for short, equals new buffered reader. Now, a buffered reader by itself can't read files. We do have to pass in a file reader to the constructor. New file reader. Then within our file reader constructor, we will pass in our file path, the location to that file. Now, our file reader object wants us to catch any file not found exceptions. We'll place that within our catch block. File not found, exception of E. Then we'll output, if we can't find this file, could not find file. We'll add another catch block just as a safety net. We'll catch any IO exception E exceptions. This is where we'll say something went wrong. This just acts as a safety net if there's something we don't anticipate. So we have our reader object. Within the try block, we will create a local variable, it's a string, of line. We will read this file line by line using a while loop. While, within a set of parentheses, assign our line equal to, use our reader, call the read line method. If we run out of lines, this is going to return null. while the value that's returned does not equal null. We'll continue reading this file. Reader is going to give us each of these words line by line. We're going to assign them to our array list of words. Take our array list of words, call the add method. We will add the current line. If there's any white space after these words, this will pick that up, and our program will consider them to be characters. We will use the trim method after line to trim that white space. Let's perform a test run. I'm going to output our array list of words. Yep, and here's our words, all within an array list. Let's delete that line. We're going to choose one of these words at random. We'll need a random object. Random equals new random. Import the class. Here's where we're going to choose our word. I'm going to copy this from the previous code and paste it. Rather than setting our word to be a hard-coded string, we're going to take our array list of words, call the get method. But we have to specify an index. With our array list, return a string at a given index. That index is going to be randomly generated by using this random object. We will pass in a random object, call the next int method to generate a random integer. The range of random numbers is going to be dependent on the size of our array list of words. Take our words, call the size method. So with our file, I have, let's see how many words, how many strings. 1, 2, 3, 4, 5, 6, 7, 8. The size method of words is going to return the number 8. Just imagine that I'm replacing this with the number 8. Return a random index between 0 and 8. That's kind of how that works. And then let's output our word for testing purposes. What is my word? This time my word was pineapple, but it's likely going to change every time you run it. Apple, lime, apple again, pineapple, grape. It really likes pineapple for some reason. Let's delete this print line statement. We'll integrate our code back into the program again. We can delete that multi-line comment. And let's run this program one last time. We should now have a randomly chosen word. I don't know what it's going to be. For me, it's 6 letters. I'll guess some of the vowels. A, there's one A. E, I, O, U. It's probably orange, but I'm going to guess some more wrong letters for testing purposes. Okay, game over. The word was orange. Let's run it again. This one is 7 letters. A, E, I, O, U. It's coconut. C-O-C-O-N-U-T. You win. The word was coconut. Alright everybody, that is a game of Hangman that you can code using Java.